All right, ladies and gentlemen, here we go. Continuing through our 8th lesson. Oh goodness, 1 second, not freeze. You are in the right spot. There we go. Okay, sorry about that. So, we are talking about multiplying polynomials today. Okay, what's important to just remember is that in contrast to yesterday, we were adding, we were combining, there we go, like terms. It's very different when we multiply. We don't have to have like terms when we multiply. So we multiply one monomial by another monomial. When we multiply a monomial by a polynomial. Okay? So what's going to happen here is we have 2 different steps. 1, 2. We'll talk about when we do that. Number 2 is basically a review of the distributive property with a little bit trickier monomials because we got exponents of variables with lots of different exponents. Now we're talking about then next a binomial by another binomial. Some people say the one thing they remember from algebra class is FOIL. Well, hopefully you also remember FOIL. We're going to do problems that look like this. What happens when we have 2 things inside of parentheses, binomial, 1, 2 terms, by another binomial with 1 and 2 terms. And then last but not least, a binomial by a polynomial, something that looks like this. Okay, what's going to happen there? All right, so without further ado, let's just go ahead and get started. So the first thing that we're going to do is multiply monomials. This is actually a review back from unit 7, beginning parts of chapter 7. If you want to write down these 2 steps here, it's not a bad idea, but it is something that we've talked about for a while. I'm just going to go through it using this example here. 5x to the second times 4x to the third. What's really happening here, obviously you're not going to write this out every single problem that you do, but as a teacher, it's really nice for me to take the time to do that so you can see exactly what's happening. My coefficients are the 5 and the 4, and really I'm just multiplying them. Okay, my variable terms are my x's. And so what happens here is we can kind of group those together. There being my coefficients and here being my x's. And you can see a little bit deeper why this becomes 20x to the 5th. Okay, yes, you could have done that probably up here, multiply the coefficients, add exponents of like bases, as it says right here. But just to show you why and how it works. Why don't you guys try a quick example here just to get yourself familiar. There we go. Just to get yourself familiar with remembering how these work. So just real quick, why don't you try one problem here? All right, I think that you're back, and hopefully you have this as your answer, negative 12x to the 4th, y to the 7th. Okay, like I said, just to review from last time, remember that this x has a coefficient of 1, or I'm sorry, an exponent of 1. The x has an exponent of 1, so add that 1 to your 3 to get this 4 down here. That's just our first step, so we're going to keep going because we got a lot to do today. Next, we're going to talk about multiplying monomials by polynomials. And just like in the previous slide, this really isn't new stuff. In example B here, our problems get a little bit more tricky, a little more complicated than we did in pre-algebra, but really this goes back to the distributive property. Okay, so step 1 here is to use the distributive property, and then step 2 is to make sure to look back on the steps from the previous slide. If you have something like what's going on in B here, where you're going to have to do 2x to the second times y times 3x. Okay, lots of stuff going on there, so just be careful. Here's our first example. You can see the arrows of the distributive property. We're going to do this 5 times each of the 3 parts of our trinomial. And so we should get 10x to the second plus 5x plus 20. None of those are like terms, so I'm basically done. Why don't you guys try B? Okay, why don't you try that one? Be careful each and every time that you remember that this is x to the 1st and y to the 1st. Now, if you need to take some time to write it out like you did here, I think that's a great idea. Okay, instead of trying to do it mentally, I think that's a great idea. Why don't you continue it from here? All right, I think that you're back. You're probably done. So hopefully you've pressed pause and finished this problem. If not, go back and do it. And therefore, your answer should be this: 6x to the 3rd times y minus 2x to the 2nd, y to the 2nd. So those are our first 2 slides for today. Just to review real fast, we did a monomial by a monomial, and then we did a monomial by a polynomial, this using the distributive property. Okay, and now is where things get really fun. Okay, now we're going to start multiplying binomials. So we have x plus 3 times x plus 2. So really, you can think about this like doing the distributive property twice. You're going to take this piece here, the x, and multiply it by each of the terms inside of there. And then you're going to take this piece here, the positive 3, and multiply it by each term inside of there. And so you can kind of split it up into this idea where you're doing x times distributive property x plus 2, and then 3 times distributive property x plus 2. This x and this plus 3 simply came from the fact that that was the first, let me erase this is not so messy. Okay, that x, this x here and this plus 3 here simply came from this term here. Okay, so then we're going to distributive property twice. We're going to get x squared plus 2x from this part here. We're going to get 3x plus 6 from that second piece there. And then we should see that there's one more step. I can put these two together. Okay, and I will end up with x squared plus 5x plus 6. Now, I don't really want you to take a long time writing this down. This is just a visual because it seems to me that there might be a better way. When I look at this in these two steps, I say, oh, that seems like a lot of work. Seems like a lot of writing things down. Can't you come up with something more interesting to help us remember? And guess what? We have. It's called FOIL. Okay, FOIL is an acronym where the F, the O, the I, and the L stand for something. So why don't we just talk about it? This is what you want to write down. If there was one thing that was the most important thing from today's notes, it would probably be this. Okay, FOIL. FOIL breaks down into the F, which is the first letter, and it stands for first. The O is the second letter, it stands for outer. Then I stands for inner, and then L stands for last. When I am multiplying, this works with a binomial times another binomial. We're going to be doing a lot of these as the algebra class progresses. I can do first the first terms. Okay, so the first parts of both of these. Okay, this is the first thing in this binomial, and this is the first thing in this binomial here. So x times x makes x squared. Okay, then I would do the outers. X times 2. Okay, these are kind of on the outsides of what this problem looks like. So x times 2 is 2x. Then I would do the inner pieces. Okay, the inner pieces are the 3 times x. 3x. And then L stands for last. The last parts of each binomial, 3 times 2 makes 6. So now these 4 parts make up my final answer, as you can see here. Although I'm not yet done because what you're always going to see is your inner and outers are like terms. Okay, the 3x and the 2x can combine to make 5x. And therefore, this here is my final answer to this problem. I'm multiplying binomials. What I'm going to do is I'm going to erase all of this so you guys can have a nice clean slate to copy into your notes. So feel free to press pause and go and copy down what it means, this idea of FOIL, into your notebooks, please. All right, I assume you have your notes already copied. Let's do some example problems. So what's going to happen here is all I have to remember is FOIL. First, x times x is x squared. However, do that one in red. X times minus 5 is minus 5x. Okay, inner, do that here in green. 2 or plus 2 times x is plus 2x. And then my last ones are going to be, I'll do that in blue, plus 2 and minus 5, which will make minus 10. I'm basically done, except for any sort of like terms that I might be able to add to that. So in this case, we're going to have x squared minus 3x minus 10. And that's our final answer. We're done, because there are no more like terms to put together. And so my job is done. I want you guys to try these 2 problems. Okay, and when we have something that looks like this, maybe I'll help you out here. X plus 5 squared. That looks like x plus 5 times x plus 5 if I were to write it out. There's a little hint up here as to how FOIL works. And I want you to try B and then stop. So do example B and then stop, and I'll give you the answer. All right, so example B, we have the first x times x is x squared. The outers make 5x. The inners also make 5x. And the lasts make 5 times 5 is 25. So then therefore your final answer was x squared plus 10x plus 25. Okay, this last, the second one, letter C, example C, a little more tricky only because you got some terms with some larger exponents on here. So let me try that one as well, and I'll come back to you. All right, hopefully you're back. I'm just going to reveal this. Hopefully you have this answer here, 3x to the fourth minus 7, I'm sorry, not x, 3a to the fourth, 3a to the fourth, my apologies, minus 7a squared b plus 2b squared. Try it again now that you see the process here laid out in front of you. If you're still not sure, bring it to class tomorrow or write down a question here on the Edmodo site and we will get to it tomorrow. All right, and this is the last slide. What's happening here is I'm multiplying a binomial times a trinomial. Okay, now we're getting real crazy and real out of hand. What's important, pardon me, what's important is that you multiply each piece by the piece of the term after it. Okay, let me explain that. 5x, we're going to split up this first one because it's only made of two terms, 5x plus 3. So I'm going to take 5x and I'm going to multiply it by every single piece of my second polynomial. In this case, it's 2x squared plus 10x minus 6. And then separately, I'm going to multiply positive 3 times each piece of my trinomial that comes after. Okay, so let's do it. If you want to just watch first so you can see what happens, that's not a bad idea. So here I have 5x times this entire thing, just using the distributive property. Use the distributive property twice. Okay, and then I'm going to do 3 times this trinomial here. Okay, lots of rainbows going on here. Multiply that out. Yes, it looks like a lot of stuff, but what's fun is a lot of like terms come together. So I have 5x times 2x squared. I have 5x times 10x. I have 5x times negative 6. That's the first piece. Then I have 3 times 2x squared, 3 times 10x, and 3 times minus 6. Once you have all of that multiplied, it's your job to look for like terms. So all of that work gets me all the way down to this here. 10x in the third is 56x squared minus 18. If we want, I can break that down into where it came from. 56x squared comes from the 50x squared and the 6x squared. Those are like terms. And then the, oh my gosh, they forgot one. They forgot a piece of this, didn't they? There should be a minus 30x on there. That's not in standard form, but we'll stick it at the end. Oh no, oh my goodness. No, Miss Bashar. I spoke too soon. I have negative 30x, and negative 30x, and positive 30x. Guess what happens to those guys? They cancel each other out. They're gone. And so then this negative 18 just comes there. Minus 11. Okay, if you were to summarize basically everything that we did today when multiplying polynomials, just make sure, what is it that you have to do? Multiply each term by every other term. Just make sure each piece gets multiplied by all of the other ones. Okay, this 2 is going to get distributed here. Okay, we're going to make sure the first times the first, the outers times the outers, the inners times the inners, and the last times the last. So just make sure every term gets multiplied by every other term. Okay? And then, if we're going to go back to our objectives, please make sure that you're feeling good about these 4 things. I think I talked a little faster today than normal. So, if you feel like I went a little bit fast, go back and make sure you know how to do things like this. Okay, there we're just doing a monomial times a monomial. What's going on there? Next, you're going to do a monomial times some sort of list of a polynomial after it. Okay, does this look like something you could do? Can you use FOIL? Okay, and then What happens when we get real crazy, when we rock it out here in mathematics, and we got a binomial times something much bigger like this. Okay? We should be able to do that. If you feel good about all 4 of those things, give yourself a thumbs up, and I will see you in class tomorrow. Have yourselves a great evening.